Going back to this, we're going to use the distributive property to show how this is exactly equal to this. X squared minus x equals x times x minus 1. Distribute the x. X times x is what?
X squared.
I should explain that. It's good, Paul. I should explain what that is. Well, this is going to take a little bit, but it's okay. When you have variables and you're multiplying variables, there are exponents even when there aren't seemingly exponents. Remember, an exponent is the number. It tells you how many times to multiply the variable by itself. Okay? So in this case, there's a little 1 there and a little 1 there. So when you're multiplying variables that are the same variable, not x times y, because x times y is just x times y. You can't do anything with that beyond what I just wrote there. But when you have x times x, and we think of the exponent 1s up here, it's essentially x with the exponent 1 plus 1, which is 2. So in other words, if we had x to the second power times x to the third power, it's simply x to the
fifth power.
Very good, to the fifth power. Might as well just say it because I'm here. X to the third divided by x to the second. What do you think you do with that?
Subtract.
Very good. So then we just subtract 3 minus the exponents, 3 minus 2, and we get 1. That's all. Okay? That's just a little tangent to help you understand this a little bit better. I don't want to erase it. All right. So x times x, which would be x to the first power times x to the first power. Remember, we're adding these because they have the same, but remember, they have to be the same variable. Then you get x to the second power. X to the second power, and then we distribute. Remember, we're using distributive property like we did here. We did 3 times the 2, and then the 3 times the 1. So the x times the x, and then the x times the 1. So we get minus x, because x times negative 1 is minus x. And is that the same as that? Yes, it is. So that's just a way to show you how factoring it, we can check our work. Now I want to explain why did it even bother factoring in the first place. Well, the reason why you bother factoring, I'm going to give you this thing called zero product property. This isn't why, I didn't really say it logically, zero product property. This is just an example of why you want to factor a polynomial. Because we want to solve the equation. That's the whole point. We want meaning in life. We want to know why we're here. That's what it is. I think about it. You know, it's almost like some people treat mathematics like a spiritual quest or something like that, and they trying to understand the meaning of the universe, meaning of life through mathematics. Mathematicians oftentimes try to understand the universe just as someone who's on a religious quest or, you know, might try to figure things out. And it's actually fascinating. But anyhow, getting back to this, x squared minus x, and explaining how the zero product property is a reason why, let me back up. We're trying to solve equations, okay? That's what really the main thing is. And the thing, again, solving problems in life, trying to figure out why we're here, what we're doing. This is where algebra comes in. So when we say, why would you want to bother factoring this polynomial? You can just assume the answer is because you want to make it easier to solve the equation, okay? It's to make it easier. Although kids sitting in classrooms think it's making your life harder, the whole goal is to make things easier. Although, you know, I was skeptical too as a kid, but it actually oftentimes, as Dave is pointing out, trying to figure out your salary, use mathematics, use algebra, use curves, and perhaps even, you know, might even use some calculus to help make things easier. All right, so zero product property.